Well, hi, good morning. Thanks so much for joining me in my shop here on August 17th. Another nice day, but nothing particularly special. Maybe raining later. Who knows? So, we've reached the point here at the radio, we're kind of at the starting gate to some degree. The starting gate for making changes of components in the radio. So at the end of the last video, I managed to get this thing working, although it's definitely limping terribly. At least what's going in the antenna is coming out the speaker. Everything in between must be there. I found a particular weakness in one of the IF transformers. Just one slug was way out, and this was kind of just killing the signal from this tube onward. It just couldn't get through anymore. So that's what was really choking the signal. But no doubt there's more choking going on here. And I think if we just take a little closer look and try to decide how to pursue this replacement of what are a dozen capacitors, I think. I'd like to do this in some fashion where, or in some order where things are revealed about the operation of the radio. Maybe just a typical operation of any radio, or maybe something specific to this particular one. And so I like to kind of take a more thoughtful approach. Well, I think it's more thoughtful approach to doing this. So a couple of targets here. One is focus on the front end, the RF area, and try to make the radio receive better. Focus on the audio end, which I think is down in this area, and just make sure that everything's in order in the audio side of things before pursuing the radio side of things. And another one is go after big capacitors that are in here, physically big capacitors. There's one right here. Probably because these are, and something else just come to mind now that I said big capacitors. These are often very important in the good operation of the radio between many tubes. That's a terrible way of putting it, but let's just say big capacitors can have a big effect on a radio. Small ones can too. What came to mind is the terrible hum coming out of this radio. That's really what needs to be pursued next. Yes, Jim, that's what needs to be pursued next. So forgetting everything I just finished saying in my nice introductory speech, I've moved on. We got to do something about the capacitors in here. So the capacitors I'm talking about are not the ones you can see back here, but let's just move this over here a little bit. There we go. Okay, get the speaker up on the turntable. I'm talking about this one and this one. Let's just look at them. They both look absolutely identical. Something very important to recognize. I'll have to pull this tube out to see it. Oh, not held in there very tight. If you look at how this capacitor is supported down here, it has this big clamp on it with a screw here to tighten the clamp. Clamp is looks like it's welded or attached somehow to the chassis here. And the clamp is clamping the capacitor can. But can you see that there's lots of cardboard or something of that sort right in here? So what they're trying to do is keep the metal of the can from touching the bracket, which is touching the chassis. So there's a reason for that, and we need to be aware of it. This is a potential shock hazard. The can here could be at a voltage quite different from the chassis. I don't know, offhand. But that's something important to look at. Number two, the other one. The other one has, I can see past here, it also has a metal clamp, but there's no insulation. So this one, the can is tied directly to the chassis. Even though they look identical, they've been wired quite differently. This one comes with a little bit of a hazard. Actually, I can read some values up here. It just says negative black, so it's talking about one of the wires. Well, I can't quite see the writing here. It's just out of view. Okay, if we look underneath, looking right here, we see a wire coming out and another wire coming out. Two wires coming out. This is on the insulated one. Insulated or isolated, I guess either word would do. The other one is right here. a lot of wires here. So there's a whole bunch of wires kind of air soldered, which is very unusual on a radio. They're just floating here. They have nothing to do with that capacitor. Thank God they're not charged, or I would have got my charge for this morning. It's got some red wires going to it, quite a few. And a resistor here and a resistor here. Wait a minute, that's not going to it, Jim. You just finished explaining it's not going to the... Oh, it is. It is, because this red wire, if they didn't bother cutting the excess off, comes back right into here. Oh, okay. You know what that says? That's a replacement. The original one had a terminal, and the repair guy has basically left the terminal. He's cut it free from the original capacitor. I've done this kind of thing. You leave everything connected to it. Now the terminal's floating. Bring in the new capacitor. No terminal on the new capacitor, just wires. And you just run the wire to where the terminal of the original capacitor went. This is a replacement capacitor. And what about this one? Well, again, it's a good chance. Let's see if the same sort of deal here. Here's a... Well, that's actually the terminal hanging here in space from the original capacitor. This capacitor is on a different terminal. No, they're tied together. Little short pieces of wire. Well, we'll have to look at this very carefully to sort out what's going on, because there's a lot of stuff jammed right in here. But that's what I think the story is. I'm going to guess this one's replaced too, because it's identical to the other one. So at some point, somebody replaced the two filter capacitors in this radio. So are they good? My experience with these radios that have a field coil in the speaker, the capacitors are very unimportant in the filtering. Weak capacitors don't seem to matter. It's a lot of the filtering is taking place in the field coil. That's how it seems to me. So often in these radios, I find the original capacitors to still be satisfactory. They only need to be 6, 8 microfarads, not the 40, 50 you'd find in a radio that's relying on a pi filter that doesn't use a coil or an inductor, just uses a resistor. You need the big fat capacitors to make that work. So the whole bottom line of this is, why is the radio humming? It's not so likely in my mind that it's because of these capacitors. And the hum is kind of a weird hum. It's kind of a buzzy hum. A little bit of a buzzy hum. So we need some positive identification or positive information, test results, something like that, to prove to us that the filtering here is bad. Before we do that though, let's study up on the schematic, and then we'll make some tests to try to convince me that the capacitors are defective and need to be replaced or boosted, at least boosted. Okay. So we're looking at the schematic here, and the filter capacitors are going to be down here in the power supply area. Let's just zoom in on that a little bit. We have the two rectifier tubes here, red spaghetti to all heaters and dial lights. Yeah, there's two big light bulbs missing in this radio. Big light bulbs. Not big, just big light bulbs. SS power switch. S5 power switch. Viewed from wire side of socket, so this is out to the speaker. There's some filtering right here. C50 and C49, and this is a 16 and this is a 25, which these are a little larger than what I commonly find in radios with a field coil. Here's the field coil over here. Now, that's the voice coil. This is probably a hum coil. Probably. I can't quite read what it says. Humbucking coil, something like that. Just reading the notes here while my eye is in this area. I might as well read some notes. Sometimes there's surprising stuff. Green finish. Black start. Green finish. Now, so the capacitors that are in here, they appear to be just single capacitors. They're not multiple capacitors where you have 2 or 3 capacitors jammed under one can. For convenience sake, they look like one each. What do I see out here? So that replacement, if these were replaced, that was done pretty early on because those are pretty old capacitors. Early on means maybe this radio is from 1937, I think, so maybe by 1942 it was humming. Somebody replaced these. These aren't very big, so easy to augment or replace. The filter here. Now there's more to this filter than meets my eye. How does this field coil get in here? Let's see. So here we got pins 1, 2, 3, 4, 5, and 6. So 5 and 6 are driving the field coil. 5 going back to the center tap. So the field coil's on the return side. And 6 is, I'm not going to be able to sort this out. 6 is grounded to the chassis. We're taking the, I said return, I'll take that word back. Not a good word to use. So what are these two resistors doing here? So 100,000 and 500,000, and then a wire off between them. So remember, one of these was grounded and the other one was not. You see, this one here is the grounded one, right to there. And the other one is not grounded, it's between something. 250 volts. It says 250 and then it says 125 in brackets. What's that mean? 125 in brackets. So there's a good chance this is producing a, let's see, no, don't say it. I was going to say producing an opportunity for a negative voltage here. There's a bit of a trick in the power supply. You generate a negative voltage, which you can then use right on the grid. There it is. That's almost certainly what's going on here. So they're biasing. One of the things we're interested in early on in the tube is the proper biasing of the output tube. You see this capacitor here? This guy is stopping a high voltage or medium voltage on the plate here of this tube from getting onto the grid of this one. Well, what can happen is over the years this gets weaker and weaker and begins to leak some charge through. The charge gets on this side, it's looking at an open wire here, so it doesn't leak anywhere, and it's looking at 1,000,000 ohms down this way, so it's a hard time leaking down that way. Consequently, this thing fills up with charge. It becomes more and more positive. In the worst case, it'll go all the way to the plate voltage, but I think that would be a pretty exciting event. Nevertheless, it gets pushed positive. Now, at the same time, it's being pushed negative by this trick, which I can't quite sort out in my head, but I know theoretically what's going on here. So what they're doing is they have a power supply that produces a certain amount of voltage, and rather than stick the ground straight on the chassis, they've stuck the ground through some resistors on the chassis. And another terrible explanation. You know what, I'm going to stop because it's just terrible. Yes, be aware when you're watching my videos. I'm trying to sort things out here. I get it wrong quite regularly. I have a pretty good high-level understanding, but when you get down to the details of each individual radio, and you're looking at different shapes of schematics and the like, it's a little hard sometimes to really reason it all out. I don't think there's any doubt that there's some negative voltage here. Did they write it up here? They did, right there. Minus 16.5 volts, right here. That's what should be there. And it will be there unless something's wrong. These resistors have gone out. Oops, power supply is too weak. Or this capacitor is leaking. If this capacitor is leaking, it will work against the negative voltage here, reduce it. So maybe this is minus 8. If this is minus 8, the amount of current flowing through this tube is increased. And this isn't current that's doing any good in the speaker, it's just there going through the tube. But what it is doing is it's depleting the cathode. It's wearing the cathode out twice the rate it should be worn out. This is already a hard-working tube, the output tubes. They tend to wear out prematurely or earlier than the other tubes anyway because of the heavy current flow through it. So you don't want to help that by lowering the bias and getting even more current. And if you got this down low enough, like let's say minus 2 volts, or worse yet, get into the positive side of things, you're going to start hearing distortions in the speaker while you cook this tube to death, basically. Now I remember right, this was strong. This tube was strong. But we need to check these things. I'm rambling around a little bit, but that's okay, because that's how you discover stuff, by spending time looking and thinking. This odd arrangement here. Well, why are they showing it like this is the R1. This is the volume control. So yeah, so the audio's coming in here to the top. What a weird way of showing it. You have the volume control with the slider. The slider's here on a separate wire that you can hardly see up through this way. There's one of those batteries. Gives the voltage right there. Minus, looks like a volt. Still have to deal with that problem. So you see how they created the bias here is by sticking a battery in. Over here they created the bias by utilizing this power supply trick, which I've so poorly described today. I'm still trying to decide what to do first here. I think we need to do some testing on this and see if there really is a hum in the output of these two capacitors. I use the oscilloscope to look at it and work out, we're bound to see a hum if I zoom in close enough. These radios always have a little bit of hum, and I think they're designed that way because to absolutely eliminate the hum costs money. So how much hum can you tolerate? And I guess the manufacturers would know the radio is going to start out pretty hum-free out of the factory, but as the years go by, it's going to hum more and more. They just want it to last long enough that they've got the new models on the market, so you can go buy them when your old radio starts humming. So cynical, so cynical. Okay, let's do some tests here. We'll do some tests here when we're operating the radio. We'll look at the bias voltage here. Is it minus 16 volts? Won't worry about any of this stuff. We'll just worry about this. Power supply and the output. Good, that's what we'll do. Okay, let's just get ready here before I turn the power on. So I have my oscilloscope running back there, ready. And here's the oscilloscope lead. Got this set to times 10 because I've got this on DC. The scope is on DC, so it's going to show the DC voltage. We want to see the ratio of the DC voltage to the ripple at the top. So first we want to verify the DC voltage on the scope. Then I can switch to AC, the DC will disappear and we'll just have this. Then I can expand it and get it really going, get a good look at it, if it's there. And it's a little tricky to make a judgment as to whether what you're seeing in terms of hum is what you're hearing coming out of the speaker. And it'll be very different on either side of the field coil. So one of these capacitors is going to show a fair bit of hum, the other one should show, we should see none, ideally. So I'm practicing now. This is on the chassis. Okay, I'm touching, this is off. I'm touching and just practicing. So that's on one capacitor and the other one, pretty easy to do. Okay, hard to get that wrong. Okay, that's good. Now we also want to measure the grid voltage on the output tube. So the output tube is right here. And it's pin number 5. And there's the little key. So 1, 2, 3, 4, 5 right here. And you can see with this capacitor. How much you want to bet? This capacitor, this one, and this one are replacements from the originals. The originals looking more like this. I'll bet you this is a replacement. So we're going to look on one side. This is the output tube side. We would expect to find minus 16 volts here. And on the other side, something like 50 positive, 75 positive, something like that. Okay. That all sounds like fun. I'm just thinking I better drink some coffee just before we do this here. So I'm going to go drink a little coffee and rest up, build up my strength for the next step. My coffee strength. Okay, I think we're ready to start here. Don't need any signals fed into the radio or anything like that. Don't need an antenna connected. There we go. Of course, I'm starting it up through the dim bulbs. Always. I have the main voltage set to 110. Can't be any higher than that. 92 volts. Here it comes. Here it comes! Okay, why don't we start with the output tube voltage on the grid. Now the thing is, when I touch this onto the grid, the voltmeter may draw out the charge, or some of the charge that's sitting there. It's a very high impedance, high tension circuit, we can call it that. High impedance, I think, is a proper word for it. So I'm going to watch the meter here. We're expecting, I'm on negative, and we're expecting 16 volts. It's going to go right over, all the way over, and even get pinned a little bit. Okay, so we're on the tube. Here we go. So it got all the way over to 15 volts, 6 volts, and that's way low from what it shows on the schematic. It shows 16 volts. So our assumption here is on the other side, I'll put this to positive now, we'll see what the plate voltage is that it's blocking. Go to the other side of this capacitor. Okay, so I've changed scales now, don't be fooled. The meters come to the same spot, but I'm on a different scale. 150 volts positive, so it's about 65 volts positive. So I would say this capacitor is leaking charge onto the grid of the output tube, pushing its bias from the appropriate minus 16 to where it is, minus 8. That's not good. That means the tube through current is higher than expected. And I'm going to use the same voltmeter. I'm going to measure the voltage on the power supply capacitors. Positive, 500 volt scale there. First one. Is that right here? It's right over. This is high voltage stuff. I don't want to make sure your hand's going. Okay, so it's a 500 volt scale. That's all of 150 volts. And the other capacitor, right here, 150 volts also. Didn't I see 250 in there? I thought I saw 250 on the schematic, and I'm reading 150 here. We should really measure the output of the transformer at this point, the power supply transformer. Oh. Let's do all that again. Oh, did you hear the total change in the operation of the radio? I've almost never had this on full voltage here. It's only 102, it's not even full. Well, that's interesting. Let's see what happened here, because let's put this up where it should be. A little higher yet. Funny things going on in there. One, that's better. Hear the kind of hum we got now? Okay, we're up around 113, 114 volts. Okay, repeat the whole thing. We'll start with the power supply voltage. Very carefully, trying to not get a shock. Okay, now we're looking at wow, that's quite a difference. 275, and up here, that's a huge difference. More than 275, 280. Well, maybe I've been operating this radio on too low a voltage while doing testing and stuff. That's okay. So now we'll look at the grid potential. It's negative 50 volts full scale now. Looking for 16 volts. So now we're on the 50 volt scale. That's 15 volts. It's right on the money. Wow, was I ever doing a bad job there, Jim, before. Okay, looking at the plate voltage of the other side of the capacitor. 150 volt scale, 75 volts. That sounds about right for a detector tube. They usually have a lower voltage on the plate of the detector tube. Okay, so that says not to worry about the output tube. The grid is running at the right potential. This replaced capacitor is probably still doing its job. And we should move on to other issues. Good. Okay, next issue is that hum we hear. Doesn't quite sound like a power supply hum to me. But let's carry on. So we'll attach this now to the power supply. And I have the feeling this is 5 volts per division here, and we've got 250 volts coming at it. We've got this on times 10 though, that should help. So times 10, 50 volts per division. Okay, I can hook it up. Let's put this line, let's put it down here. Here we go. First one. Oh, I hate going in there like this. I don't like it. Okay, clipped on. So we went from this line all the way up to this line. So I think it's 50 volts per division. That's a lot, isn't it? So starting here we go. 50, 100, 150, 200, 250, almost 300 according to this. Well, 275 is almost 300. And I'm not doing anything with great precision here. Now, how much hum is on there? So when we look at the whole DC voltage, the amount of hum is pretty minor. Let me slow down my scope a bit and see the wavy line a little better. So we'd like to know, what is this as a percentage of this, of the whole thing? Pretty small. It's pretty darn small, isn't it? When you just look at it, you can tell that's quite small. Now I'm on one capacitor. I'm on the one that's insulated. Wasn't that the second one? We'll switch now to the first one. Okay, just disconnecting here. Okay, now we're going over to the other capacitor. So looks about the same, doesn't it? Can't really. Wow. I mean, I've seen radios where, this DC voltage has got, a 10% variation in it. This has got would that be 1%? I don't think that really explains what we're hearing coming out of the speaker. Yeah, I think that sound from the speaker is something else. Okay, so decision time. The decision is, I'll still change that green capacitor out because who knows how long it's going to be here operating properly. I'll put a new one in that's going to be good for 50 years. Could it be these guys, these two batteries, causing this hummy sound? Gee, I just don't think so. Then I'm pretty sure there's no battery voltage here at all. Well, you know what? These batteries are on the grid circuits of two tubes. At least one of them is. The other one I haven't spotted yet in the schematic, but I assume it's also on the grid circuit. And if the impedance of the battery, because of its condition, has gone way up, so in its early stages, when it's new, not much resistance in a battery, not enough to affect this kind of circuit. Well, maybe now there is. Put a huge resistor in the grid circuit and you get this kind of sound. This kind of, or if you leave the grid open, say a grid connection is broken and the grid is open and there's a bit of wire in the radio, you can get this kind of hum out of it. Well, I could short these out. I could short these out temporarily. See what happens to that sound. Let's try that. Is that a dangerous thing to do? No, I don't think so. It's just a grid circuit. At least one of them is. You know what? I only know where one of these batteries is. I think I better make sure. I'm going to stop, look at the schematic, find the other battery, make absolutely sure it is what I think it is. What else could it be? Okay, that only took a moment. One battery is biasing one tube and the other battery is biasing two other tubes. In the case of the one that's biasing two other tubes, they're the two front end tubes. It's probably this battery, come to think of it. How can one battery bias two grids? Okay, I'm going to stop thinking now. I'm just going to go ahead and do this shorting thing, the result of which I'm not absolutely sure. What is the volume here? We didn't even have the volume turned up. Wow, it does sound like a radio, doesn't it? Like zero difference here. There's my clip lead tester. I'm suspicious of these clip leads all the time. Now, let's just try another clip lead. I don't have any reason to think the clip lead is bad, other than nothing happened here. Well, it shows you the effect of that battery. Now we'll try this one. Oh. Hot diggity dog. What happened there? There's my other phrase. Hot diggity dog. Knock down the hum, the buzz, increase the signal. Oh. Okay, so these are grid circuits. This wire's shielded back here. That's our big message that if you let the wire pick up junk, you're going to get feedback and squeals and all kinds of weird stuff like that. Okay, that's an interesting little experiment. It seems to me I should be shorting these out at this point. Well, this one made no difference at all. Shorting them out. Or getting them to go. Now I have heard tales of people drilling a hole inside these batteries through the case, pushing in water, and then soldering them back up. Never tried anything like that. Obviously, Coffee's the issue here. I just got the urge to try to actually receive something with this radio, so I have it connected to the outdoor antenna. Shortwave. The signal's fading in and out a bit. Okay. It got quieter. Got a hummy sound. It's hard to hear now. Gone. So I think basically we're looking at an open grid here, or high impedance grid. Inappropriately, it's picking up signals right here. And that hum is coming there, I believe. Let's try, as crazy it is, what can we get on the broadcast band? Broadcast, sounds good. With the same level of hiss as the shortwave band. That's a good sign. It's picking stuff up, but it's all noise here. Hear an alarm going off in the background. I must go and attend to something. Yeah, this is the part where it gets right where there's potentially stations to pick up. Okay, gotta go deal with something. We're gonna try another antenna when I get back. So this is about the longest I've had this radio playing so far. I'm going to feel the power transformer and see if it's getting hot. And it's cool. Quite typically we have a radio that will work on both 25 cycles and 60 cycles. The transformer runs very cool at 60 cycles, so that's actually a funny advantage. So this is the lead now from a loop antenna, which I'll show you in just a second. I'm just going to connect it up here. Just going to go. Oh, that's interesting. Hey. Everything is interesting. The loop antenna. It didn't make much difference there, did it? The loop antenna has an interesting characteristic. It's very low impedance, which means you're almost hooking up a short on your radio, but at the same time it produces a strong signal. So even though, and the result of that is it kind of runs with a low level of noise. That's my understanding of all that. I got this right? Why don't we put this on here? I'm sure it's the same thing, but we'll do that. Okay, a little bit of volume. Now we're tuned to around 800 or so. The loop antenna is a tuned antenna. And here it is. Okay, so this, don't laugh now, this is something I slapped together when I was in college. Yes! I have dragged this with me since I've been in college. Let's just do this. Try not to knock things over. There we go. There it is. Tunable. I will tune it. Not much response from the radio. Well, that's not very good. Well, you get quite a response. This button adds a chunk of capacitance to the variable capacitor to increase the range of the antenna. How come that didn't make any difference? Have I done something stupid here? It really is very, very surprising. These wires are really worn out here, right where they go through the chassis. Are they shorting? I kind of doubt it. I think you would have heard some crackling there if that were the case. Well, a little disappointing. We can't use the loop antenna. Oh! No. Definitely on broadcast here. Let's go down where there should be a station. Down in the scratchy zone. Oh, maybe the scratchy zone is where it's working. Let me tune the antenna here. Let's see what we can get now. Nothing. Okay. So if you're just hearing some kind of roar come up in my house, it's the air conditioners coming on. Well, aside from that, somewhat disappointing result. I can't believe it didn't produce anything. I have another loop antenna. Let's try another one. Okay, here we go. Disconnect. This is the big loop. You can see the small loop, same thing as the other antenna, tuned with this knob here. Except I sure didn't make this, I bought this. Nice little antenna. It's called an AN100. Okay. I'm going to hook it up. No polarity in a loop antenna. Full volume. So it's showing no sign of like there should be a moment where the hiss shoots up when I'm tuning this antenna. Boy, that's terribly shrill. There's something here. Do something with that. Yeah, okay, enough of that. Okay, so what do we got here? On shortwave, come on. Okay, frustrations building here. Shortwave. Broadcast. Let me turn this up. Broadcast. making sense. Let me try a different wire arrangement here. Maybe what I've done here isn't right. Let's try this. I don't think that's going to make any difference from previous experimenting. What's happening here? Must be bad lead between the antenna and the. Yeah, let me try a different kind of. Do something different here. Okay, I've got a different way of connecting the antenna to the radio, just using the different leads and clip leads. Nothing whatsoever. That's 2 loop antennas not showing a response. Yet. That's the ground. And if we short the antenna to the ground, we don't get an elimination. Go to short wave. We get an elimination. So this is now suggesting, yeah, that burned coil is not doing its job. That if there's any signal getting through here, it's cheating its way through. Which is possible. But I'm left with the impression this coil is shot. And that's, if I had to lay odds, just looking at it, that's certainly how I would bet that it's shot. Even though we've gotten some indications that it's okay. So we don't know. We don't know for sure. Still don't know for sure. Wow, what have I done today? Not much. Yeah, not much. We haven't done anything to the actual radio. I'm still in the mode of trying to understand what's going on with it before I get in there and make the situation worse by accident. I guess that's how most situations get made worse. It's by accident. So I have to make a decision here whether I want to start changing those capacitors or I want to continue trying to determine what's going on with this radio. Sure does seem like this coil is the problem. Yeah. That's about all I can say about that. Well, I'm going to change this capacitor anyway and get something useful done here today. This won't affect the operation of the radio, as we now know. Power it down. Well, the good news is the power transformer does not heat up. That's very good news. We have to do something here about this. Maybe I'll do a little research on the internet. I generally don't like to do that, but I will. See what other people say about these things. I'm sure in the past I've heard stick a resistor in, just short it out, forget about it. I'm sure I've read that. But you know, every radio is a little bit different, and what they're doing with these guys, although you know, applying a bias is what they're doing in different radios, things are a little different. So perhaps just shorting them out isn't the best move. Didn't seem to make any difference at all up here. Yeah, I think there's still too many question marks floating around here for me to start getting in there and changing all kinds of parts. Even though the problems I'm having may be because of those parts. So let's do that one capacitor there. Oh, I almost forgot. We should test this capacitor that we took out. This is a great opportunity here. It's an older capacitor, appeared to be doing its job in blocking DC. Appeared to be doing that. There are circuit parameters which can make that situation more or less problematic. The leaky capacitor, I won't go into that. Like in some cases, a little bit of leak, it probably wouldn't change the bias voltage at all. So I'm hooking this up now to a capacitor checker. What this will do is put some voltage across the capacitor, and then it will detect any leak that's happening through the capacitor. It'll utilize this magic eye here, which is just coming on now, to do that. So the magic eye is really hard to see always in this camera. What can I possibly do to make this more visible? Okay, why don't we give that a try. So, if you look carefully, you can see there's a pie-shaped opening down here. So I'm going to throw this switch. When I do, it's a spring-loaded switch, so it always pops back to this normal setting. When I do, I'm going to put not 25 but 50 volts onto the capacitor, and then we will see what happens. Watch the eye now. Okay, do you see it? It closed briefly and then opened wide. Okay, so the closing briefly is a charge flow, which it looks like a leak. But once the capacitor is charged up and the charging current stops, any current that's left is leak current. There was none. What about at 150 volts? Yeah, it's still opening up. So this is actually a very good, very good capacitor here. Oh, it's the wrong size. It's got a 0.01 here. This should be a 0.005. This is twice as large as it needs to be. Would that affect the radio? Probably not. Probably not. Okay, and what's the voltage rating on it? 600 volts. Okay, let's give it 250. Still opening right up. So, as you know, capacitors coming out of old radios, this one's really good. So I think that verifies lots of things. Verifies the test on the radio. Verifies my capacitor checking techniques. Which I'm always. So there we are. Too bad for you. You could have stayed in there. But you know, how much longer would this last? Well, that's an interesting question. How much longer would this capacitor remain good? My guess, a long, long, long time. Because if it made it this far, if it's been in the environment for, let's say this was done in late 60s. It's been in there since then. Maybe in the 70s. It's still many, many, many years, and it's still in good shape. So its rate of degradation is extremely low. Plus it may have sort of sunk to a permanent operating condition. It may be unaffected by the external environment. It may be perfectly sealed. So whatever's going on is going on inside it. There's a little bit of chemistry going on. There's some stuff left inside here that isn't fully reacted. Basically ionic contamination of paper and stuff like that they build these with. And just maybe over a little bit of time that stuff goes where it's going to go, and then it's gone and it's done, and the capacitor adopts a final state that it stays in for decades and decades and decades. I think that's the case with this one. So but this is you know, we could put this in another radio. It's good. It would compare favorably with absolutely brand new capacitors. So did I need to change that? I don't think so. These ones, I'm sure, these older ones, these have got to go for sure. And I'm going to change these anyway because we're here, and that's what we're here for, changing capacitors. These ones, this is a Cornell Doublier capacitor. These are bad actors, I'm pretty sure. So it'll be interesting when we change these out, what we find out when we test them. Well, okay. I feel like I moved forward today. Got one capacitor done. Got a little better understanding of the radio. Still question marks around the burned coil. And the rest of the radio seems to be operating fairly well, in fact. Fairly well, considering. Okay, well thanks a lot for watching. And tomorrow I'll just press on a little further.